Tanya Rowling, helping you to solve Maths, CBSE Class 10 NCERT syllabus, and my sister Tina Lofus would be teaching CBSE Class 8 Maths NCERT syllabus. Alright, now let's get into the video. Today we are going to be learning exercise 1.3, third question, third subdivision. Now let's read the question. So the question is, prove that the following are irrationals. So the third subdivision is 6 plus root 2. So this is the third subdivision. So this subdivision, it is really easy. First of all, we should find the root 2 is irrational. Okay, we should find for root 2 and then we can find for 6 plus root 2. Okay, first let us write, let us assume root 2 is rational number. Now let's write that. So let us assume root 2 is rational number. Okay, so here it is irrational. For now we are taking it as rational number. That's because we should get a proper answer. Okay, and then at last we can write which is a contradiction. That's why we wrote, instead of writing irrational, we wrote rational number. Okay, so if it is a rational number, we should write it is in the form p by q, where q is not equal to 0. So therefore root 2 is equal to p by q, comma q is not equal to 0, where p and q are coprimes. Okay, I had already uploaded what are coprimes. Let me just say what are coprimes. So coprimes means if you are not getting a particular HCF for two numbers, then what we do is we write 1 as a common for HCF. So we take HCF is equal to 1. So that 1 is a coprime. Okay. So we took root 2 is equal to p by q, where q is not equal to 0, where p and q are coprimes. Okay. So now let us square it. Before squaring it, we should do certain things. So now let's do that. First let me write root 2 is equal to p by q. So here it is in the fraction form. That means here also it has to be in the fraction form. So I am going to be writing 1 down here. So now we are going to be cross multiplying it. So we shall cross multiply root 2 into q and 1 into p. So when we cross multiply, we get an answer, that is root 2 into q is root 2q is equal to 1 into p is p. Okay, so simply if we write p means it is 1 only. Okay, so we shall write p. Okay, now let's square it. Squaring on both sides. So squaring on both sides. Now let's write this form, that is root 2q is equal to p. So root 2q is equal to p. So here we should square it. That means we should write square. So here root 2q the whole square, and here it is p square. Okay. So this square belongs to root 2 as well as q. Okay. Now what we shall do is, I am writing in pencil. Why? Because now I am going to be explaining it for your understanding. Okay. So here it is root 2 q the whole square. Am I right? So here this square belongs to 2 as well as q. So we are going to be cancelling the square which belongs to 2. So root 2. Okay. So we are cancelling the square. Here also root 2 means this root is a square. So we are going to be cancelling this also. Okay. For example, here let me show. So it is root 2 square. So I cancel the square and I cancel this root. That means it is 2. Okay. But one more 2 is there for this q is equal to p square, and we shall write, we cancel this and this, that means it is 2. Okay, it is 2 q square. Okay, because the one square belongs to q as well. So it is 2q square is equal to p square. Okay, this is equation 1. So now let's write 2 divides p. So now let's do something, that is, we shall write this q square as it is. So let me show that, is equal to p square divided by 2. So why did we write this? Because here it is in the multiplication form. When it comes this side, I mean when it crosses the bridge, that is equal to, this is the bridge, when it crosses this bridge, when it comes to this side, it changed into division. Okay, whenever you have multiplication thing like this, here it is 2 into q square. So we should take this 2 across here, and when it comes this side, then it became 2 divided by 2. Okay, so p square divided by 2. Remember this is very, very important. So now let's write p square divides 2 and 2 divides p. So now let's write 2 divides p square and 2 divides p. Okay, why are we writing p? That's because in the first step we took root 2 as rational number. Okay, why? Because a rational number is always in the form p by q. So we are supposed to take p as well. So first we wrote the actual one, that is p square, and then we wrote for rational number. Okay, to get a proper answer we write it like this. Okay, don't get confused in this. Okay, now what we shall do is, we shall put p is equal to 2a. Instead of p, we should write 2a. So we took it from equation 1. Let me show that equation. So this is the equation. So this is the equation 1. Here now the equation is 2 into q square is equal to p square. We are going to write this. Okay, now let's write that. So now let's write 2 into q square is equal to p square. Okay, now let's write 2 into q square is equal to, here instead of p we are supposed to write 2a. So 2a, and p has a square, so we should write 2a the whole square. Okay, so this 2 belongs to 2 as well as a. Okay, now let's write 2q square is equal to, so it is 2 square and it is a square, am I right? Because this 2 belongs to 2 as well as a. So 2 into 2 is 4. So we shall write 4a square. Okay, so we solved this one, and a has a square, so we wrote a square. Now what we shall do is, we shall write, let me show that. So I am writing this 2q square. This is simply I am writing it is equal to, I am writing this as it is. Okay, because you guys should see it right over here, no, that's why I wrote it. Okay, okay, don't need to write it once again, I am, for your understanding I wrote it. So now it is 2q square is equal to 4a square. Now q square is equal to 4a square divided by 2. So here it was in the multiplication form. When it crosses this bridge, that is the is equal to bridge, when it comes to this side, then it changed into division. Okay, so whenever you have a multiplication form in this side, that is 2 into 3, sorry 2 into q or 3 into q, something, if you have some other number also, if it is in the multiplication form, then after what we should do is, we should come to the next side by crossing this bridge, and it changes its sign, that is from multiplication it changed into division. Okay, so now it is q square is equal to 4a square by 2. Now we shall cancel it. So as you guys know, 2 ones are, it is 2, and 2 twos are, it is 4, and a square as it is. Okay, so the answer is q square is equal to 2a square. Let's write that. So q square is equal to 2a square. So, here it is in the multiplication form. When it crosses this bridge, that is equal to bridge, and when it comes to this side, then it is in the multiplication form. So, we shall write q square divided by 2 is equal to a square. Okay. So, we just came this side and it changed its sign into division. Okay. So, now it is q square divided by 2 is equal to a square. Now, what we shall do is we shall get this a square this side and we shall take this whole term this side, that is the right side. So, you guys might ask, why are we taking like this? Because we should write that 2 divides q square. For that it has to be in this side. Okay. So, for a square the value is q square by 2. So, we are supposed to write the value in this side and the main thing right over here. Okay. So, here we are mentioning for a square the value is q square divided by 2. Okay. That is why I wrote it like this. Now, let us write 2 divides q square and 2 divides q. We are writing q, that is because in this question it is mentioned that irrational, but in the answer what we did is, in the first step I just wrote rational number. Now, let me show that. So, here I took rational number instead of writing irrational. That is because rational number is in the form p by q, and where q is not equal to 0. So, I wrote rational number. Okay. That is because for getting a proper answer we took rational number. Okay. Whenever you get like this root question, so like this sort of question, that time what you are supposed to do is, first of all you are supposed to write, let us assume root something, whatever numbers you get in that particular place, root something is rational number. For example, 2 means root 2 is rational number, or root 3 is rational number. Why? Because for getting the proper answer we are supposed to take first that particular value as rational number. Okay. For that only it is always in the form p by q, it does not have a square or something. So, I took q. Okay. I did not take q square. So, 2 divides q square and 2 divides q. So, now let us write p and q have a common factor, which is a contradiction, and therefore root 2 is not rational, root 2 is irrational. Let us write that. So, now I wrote p and q have the common factor 2, which is a contradiction. So, therefore root 2 is not rational, root 2 is irrational. Okay. So, here it has a common factor 2. Why? Because here 2 divides q. Likewise, in the previous thing also we did that 2 divides p as well. That is why it got a common factor 2. So, which is a contradiction. Contradiction means a conclusion. So, after conclusion, root 2 is not rational, root 2 is irrational. Now, let me explain what is the meaning of contradiction and why did we write that. Okay. So, contradiction means, here in the question it is mentioned that we are supposed to take irrational, but instead we took rational number. So, that is why we wrote contradiction. So, you guys might ask, why did we take rational number? That is because rational number is always in the form p by q, where q is not equal to 0. So, we can't write that irrational number is always in the form p by q, where q is not equal to 0. That is totally wrong, because in mathematics rational number is always permanently it is in the form p by q. Nobody can't change it. Why? Because that is the rule. Okay, it is in the form p by q, where q is not equal to 0. So, in order to prove that we get irrational number, in order to prove root 2 is irrational, we are supposed to write that it is rational number. And after solving these things and after getting a proper answer, we write it as contradiction. That means the true statement is irrational, but instead of writing irrational we wrote rational, that is a false statement. So that is the meaning of contradiction. Instead of writing the true statement, we wrote the false statement. So for that, after doing the contradiction, we say that root 2 is not rational, root 2 is irrational. Okay, now let me show that. So here you guys can see root 2 is not rational, root 2 is irrational. Finally, we accepted that root 2 is irrational, okay, and that too we also accepted that we took a false statement, that is the rational number. Okay, I hope you understood this. Now what we are going to do is we are going to be finding 6 plus root 2. Okay, now we found for root 2, still we should do 6 plus root 2. So let us assume 6 plus root 2 is a rational number, where 6 plus root 2 is equal to p by q, where q is not equal to 0, where p and q are co-primes. So we wrote this. We wrote p by q, that's because we took it as rational number. Okay. So now we took 6 plus root 2. We are going to be finding 6 plus root 2 was irrational. Okay, first we found root 2 was irrational and we proved it. Now we are going to be taking the whole thing, that is 6 plus root 2. Now let's take this value, that is 6 plus root 2 is equal to p by q. So let us write 6 plus root 2 is equal to p by q. So here it is in a fraction form, that means here we shall write divided by 1. Nothing is there, so we shall write divided by 1. Now we are going to be cross multiplying it. So we shall cross multiply 6 plus root 2 into q and 1 into p. Okay. So 6 plus root 2 into q is 6q plus root 2q. So 6q plus root 2q and 1 into p is p. Here you guys might ask, how it is 6q plus root 2q? That's because we multiply this whole term, am I right? That means this q belongs to 6 as well as root 2. That's why we wrote 6q plus root 2q, because we are multiplying it with q. Okay. For example, so 6 plus root 2 into q. Okay. Here now this q belongs to 6 as well as 2. So it is 6q plus root 2q. Okay. Remember this. Okay. This is somewhat confusing. Don't get confused in this. Okay. So now the answer is 6q plus root 2q is equal to p. Now what we shall do is, we shall take this term, that is root 2 into q this side. Okay. So let me take that. So 6q. So this term it's crossing this bridge, that is equal to bridge. So it comes this side. So that means here it is root 2q. Okay. It is in the root form. Okay. So it is root 2q, and when this p comes this side, when it crosses this bridge, then it is minus p. Am I right? Why? Because here it is in the addition symbol, that means plus. Okay. So it is plus. So when it comes this side, then it is minus. Okay. So it's coming like this. Okay. So this, when this plus comes this side, crossing this bridge, that means is equal to sign. When it crosses this is equal to sign, then it is minus. Okay. So that's why I wrote minus p and is equal to root 2q. So here it is root 2q. Okay. Now what we are going to do is, so you guys might ask, we don't need to change any sign for root 2q or what? We are not going to be changing it. That's because it is already in the form root 2. Okay. So root means it is not plus or minus, it is both plus and minus. Okay. So that's why it is in the form root 2q. So no need to change any sign. Okay. So now 6q minus p is equal to, here this q is there, no, it is root 2 into q. So this q comes this side, when it crosses this bridge, that is equal to bridge, when it crosses this and when it comes here, then it becomes in the division form, because here it is in the multiplication form. So, whenever there is a multiplication form right over here or right over here somewhere, when it crosses the bridge, then it becomes division. Okay. So, here the q comes this side and it changed into division. Okay. And then it is root 2. So, you guys might ask, why are we doing these things? That is because we are doing it because already we proved root 2 is irrational. Okay. So, for the root 2 has to be separate. So, we separated root 2 from the rest of the things. So, here 6q minus p divided by q is equal to root 2. Already we proved root 2. So, we shall write root 2 is irrational. So, we know that 6q minus p is equal divided by q is rational. Let us write that. So, we know that root 2 is irrational. Of course, we solved that root 2 is irrational, then we know that 6q minus p divided by q is rational. Okay, it is rational. So, due to contradiction, 6 plus root 2 is irrational. Okay. So, contradiction means changing rational into irrational. So, first of all, we change irrational into rational. Let me show that. So, here we change, instead of writing irrational, we wrote rational number. That is because to get a proper answer, we should change from irrational to rational. That is why in the last part we wrote that it is a contradiction. Contradiction means it is a conclusion. So, just because of the contradiction, we change from irrational to rational. And in the end of the question, that means after solving the question, before getting an answer, we should write that it is a contradiction because we change from irrational to rational number. Okay. So, why are we taking rational number? That is because rational number is in the form p by q, where q is not equal to 0. So, p by q, you can see that in mathematics, rational number is always in the form p by q. We can't change it into p square by q square because that is the rule. Okay. So, that is why to get a proper answer, we took rational number. So, we wrote due to contradiction, 6 plus root 2 is irrational. Let me show that. So, here 6 plus root 2 is irrational because of the contradiction. I hope you understood what is contradiction. Contradiction means conclusion. Okay, don't get confused in this because this is a simple one. Okay, so finally we solved this. This was pretty big. Why? Because we should solve the roots 2 as well. So after solving it, finally we got this answer and we solved it. Thank you guys for watching this video. Please like, subscribe and help your friends by sharing this video. If you have any doubt, you can comment me in the comment section. Catch you in the next video. See ya.